Hello. I'm admitting everybody in. I have to keep clicking a button to admit people. Okay. I have to keep admitting people. Okay. Looks like. Can everybody hear me?
Yep.
Okay. It's a large group. There's probably around 40 people, or there could be as many as like somewhere between 30 and 40 people. I have to keep admitting people.
I think there might be an automatic button for that somewhere in the.
Yeah, really, that'd be helpful because I have to keep pressing it.
Yeah, I was going through some of that stuff earlier because I'm gonna have to deal with this myself. So if I find it again, I'll let you know where.
Yeah, because somebody complained yesterday that they joined the class about a half hour late and I never let them in.
Yeah,
Because at that point I wasn't even paying attention to the admit button.
Right. I'll see if I can find it again and tell you where it's at.
Yeah, that'd be real help. Let's see. Oh, one person's waiting. Admit. Okay. Okay. I think we got everybody in so far. Okay. Hello. This is the graphics class. Okay. We're going to meet like this with Zoom every Tuesday and Thursday at 12:30. Okay. And this is these meetings will be very similar to what we did in the classroom. I'm going to be showing you how to run the software. We'll do lots of demos and examples of using the code that we're going to be looking at. This class is going to be a course on graphics. And the way we're going to learn graphics is to look at code that I wrote essentially I implemented a small graphic system. So we're going to be looking at a handmade graphic system so that the idea is instead of being told this is what your graphics card does and never really actually be able to see how it really does it, we'll actually look at real graphics code and we'll see all the algorithms and all the data structures that a graphics system uses. So, and the only way to be able to do that is to write the graphics code yourself. Otherwise, you're using libraries or hardware. And I've read many books on graphics, and it's kind of disconcerting because most of them just say, this is what the graphics card does, and then they kind of just wave their hands and give you vague descriptions of what the graphics card does, because the graphics cards are all proprietary. You actually can't see, they're hardware for one thing, and they're proprietary. You can't really see so much of what's inside them. So I think a good way to learn this is to write everything as real code in Java. So we're going to implement a 3D rendering engine in Java and see how it works. And the way we'll do is we'll build a system from scratch. So we're going to start with a real simple babyish renderer and just keep adding features to it. There's going to be a total of right now I have about 20 renderers and think of them like chapters in a book. They just keep adding more concepts to what a renderer does. So we start with the very basics, the very most bare bones feature that a renderer has to do to create 3D computer graphics. And then we add features to it and see how it grows. Okay, so there's no textbook for this course. The textbook is actually the code itself. One of the goals of this class is for you to learn to read a medium-sized body of code. Like, you're right now in school, you mostly read textbooks and you read code that's examples in the textbooks, which are rarely more than a page or two long. For this course, you'll be reading a body of code that's a few thousand lines long. Okay, so your job is to get used to the idea of somebody just saying the documentation is the code. That's an old joke in Linux land. When you have a question about a code, instead of saying read the docs, they'll just say read the code. Everything you want to know about a program is in the code. In truth, that's kind of not the best answer to give someone, but this is the goal of this class will be to get you started with the idea of learning by reading code. So it's by modern standards, this is going to be a medium to small size project. It's going to be only a few thousand lines of code. That's still probably bigger than most of anything you've read. I'll show you in a little while. It's going to be divided in about 20 or 30 files. It's a project that's 20 or 30 files in the total of it starts off at about 1,000 lines of code, and it'll grow to be a few thousand lines of code. Okay. All right, now what I'm going to do, and we're going to do most of the time, is I'm going to share my screen so I can use my desktop to show you stuff. Just like if we were in a classroom where I would project the computer to the screen, I'll just share my screen here. And if you have any questions while we're, you know, there's a little raise your hand thingy in Zoom that usually doesn't work for me because it's kind of hard to see so much stuff going on. If you have a question, don't raise your hand, just unmute yourself and just ask a question. Yeah, the best way to ask a question, especially with so many people in a meeting, is just go ahead and unmute yourself. If you have a question, just interrupt me, just yell out, hey you, and just stop me and ask a question. So if anything seems, if you think anything's wrong, if you think I made a mistake, or if you have a question about something, please just unmute yourself and just ask. So I'm gonna click on share desktop, make sure this works, okay? Okay, so you should see my desktop now. Does that look right? Oh, we'll see. Oh, I have 5 people entered the waiting room. Okay, so I still got, okay, admit all. Do you see the little waiting room thingy? Do you see this?
Yeah, black box right there.
Oh, you see it as a black box?
Yeah, I don't see anything inside it on my screen.
That's weird. That's how, okay, that's how, yeah. So it's on my desktop, but it's part of Zoom, so you just see it as a black box. Probably that's so you don't, I don't know why that, yeah. Okay, so, but I have to pay attention to that because as people come in, I have to let them into the room. Okay, all right, so you see my desktop. Okay, I'm gonna start up a browser. Let's see. Okay, so everything you need for this class is going to be on a course website. So if you Google my name, this is a link to my university website, and then this is a link to the graphics course website. So there is a Brightspace thing for this course, but I'll put, and you'll use it for submitting homework assignments. That's where homework assignments and grades will be kept, but all the course material will be on this course website. So here is the syllabus for the course. Here's the page that has the reading assignments for the course. Here's today's first reading assignment. This is where you'll download all the software from. And then here's the page that has homework assignments. There's already a homework assignment up there. We'll talk a little bit about that as we go on today. So there's the first programming assignment. It's due in 2 weeks, okay? Right. So here's the syllabus page. Notice that there's no textbook. I didn't put a remark here. The textbook is really the code that we'll be downloading and looking at. So you'll be reading code, and I put a lot of documentation into the code. I put lots of comments in the code. So I hope the code is readable. There's even a style of programming. There's something called literate programming. You can Google it, you can read about it. That's more or less what I'm trying to do, is I'm trying to write the render in what's commonly referred to as the literate programming style. This was invented by Donald Knuth, one of the most famous computer scientists in the country. And it's a style of programming where you try to tell a story while you're writing your code. Okay, so I hope that the code is very well documented so that it really explains what's going on. So that'll be your textbook. Okay. Here's the details of the syllabus. There's going to be a bunch of programming assignments. There's going to be one every week or two. Some are going to be small programming assignments, some will be bigger ones. And then there's going to be a midterm and a final where I'm going to ask you questions where there's a lot of math in computer rendering. So the exams will emphasize some of the mathematical formulas that get used in rendering. So the exams will ask questions that you can understand. There's a lot of use of equations and matrices, and also there's also a fair amount of object-oriented programming. So the exams will be asking you questions where to show that you can read graphics code and make use of the formulas that we'll be learning about. So there'll be 2 small exams, okay, and they're worth they're worth 20% each. Be one about the middle of the semester and then one at the very end of the semester. And then there'll be a bunch of programming assignments. Okay. And office hours, if you go back to the opening page, here's a link to the Zoom meeting that we'll have every day. This link should work for every Zoom meeting. it's a reoccurring Zoom meeting. So I think that, that link should work every Tuesday, Thursday at 12:30. Then here's a link for office hours. I'm going to have office hours every Monday, Wednesday at 2:30, at 2 o'clock. And then I also teach in Java, and I'm teaching the CS 123 class. Probably the office hours will be mostly with the Java students. If you have any questions, you can always just send me an email or ask me to meet with you by Zoom. So if you don't want to go to office hour, because I got a feeling that the office hour will be occupied by a lot of the students in the freshman Java class. You can always just send me an email to ask a question, or send me an email asking me if we can make an appointment to meet with Zoom. The nice thing about meeting with Zoom is you can share your screen and I can share my screen, and I can see how your code is. It's just like as if you came into my office with your laptop. You can just, in a Zoom meeting, you can share your screen just like I'm sharing mine with you. And you can't share screens simultaneously, but you can take turns sharing screen. And so you can, we could work on code. You could show me your code. You could show me how programs are running. So it'd be a good way I think it'll be a good way to ask questions. Okay, so there's link for the course and link for the Zoom meeting. Okay, the syllabus is pretty much boilerplate. There's nothing new in the syllabus that hasn't been there in all the other syllabuses, any courses you've had. Okay, then up here on the course website, the most important page is this one. There'll be an entry for each day that we meet that'll tell you what the reading assignment is. There'll be links to, so like here, I try to give you links to little things that are interesting. Like here's Pixar created a nice little movie on what rendering is. Okay, so watch this movie. It's just about 2 minutes long. Okay, so that's a little course that the Pixar created for Khan Academy on graphics. Okay, and it's got a nice little intro video. Okay, so watch that. And then here's a kind of interesting thing. There's this book. It's kind of a fun book, How Software Works. It's got chapters on all kinds of interesting ideas in computer science, encryption, web security, movies, games. And what's interesting is the chapter on movies and computer graphics is made as a free sample. So that makes a nice introduction to what we're going to be doing in this class. So read this chapter on computer graphics. It makes actually a very nice intro to the ideas we're going to talk about. Okay, so watch this Khan Academy movie and read this one chapter. And then another thing to read as an intro is, this is a graphics book that a professor wrote online. It's kind of a traditional graphics book, except that it's available online. It teaches graphics using JavaScript. But it's got some nice explanation of the ideas in it. So I link you to 2 sections in that book that are good introductions. So read his introductory chapter on I'm painting and drawing elements of 3D graphics and hardware. So it's a nice overview of computer graphics. Read that. And another thing that I think you should read would be this section 2.1 about pixels. That's mainly what we're going to be talking about today. This chapter here is what we're going to be talking about today, pixels. Your first programming assignment, the one that's out already, is about pixels. Okay, so this is the main thing of the introductory material. This is the one that's most pertinent to doing the first homework assignment. Okay, all right. So, okay. And then this is the code we're going to look at. I'll download that in a minute. We'll start looking at it. That's the first renderer. The code is just in a zip file, so we'll download it. And but actually you also need to, I'll show you in a minute, you need Java on your computer. And in particular, I'll show you which version of Java this is set up to use, okay? And a minute ago, we'll talk about these pixel utilities for looking at. Remember this section here is about pixels. This is a zip file put together of some programs that make it easier for you to play with pixels. So we'll play with pixels, okay? And then this stuff here is just, I think it's kind of neat. If you just want to see demos of computer graphics on the internet, most of this stuff is written in JavaScript. The beauty of JavaScript, the ugliness of JavaScript is JavaScript. The beauty of JavaScript is that it runs in a browser. So you can write all kinds of interesting software running in a browser. Yeah, this is live 3D graphics running in a browser, all written in JavaScript using a graphics engine called 3JS. Okay, so these are demos of what 3JS can do. Okay, and there's a whole bunch of these kinds of systems out there. This one's called 3JS. Here's another one called Babylon. I think this one's from Microsoft. It's another JavaScript 3D graphics system. These are live. Oh, and all of these are actually live graphics. And somewhere on here, there's usually a button where you can see the source code. Okay, I don't see it here right now. So, oh, well, here, click. There's the documentation for what the example's doing. So this is all on the internet. So, you know, there's the demo.
So you add view source to the beginning of the URL.
Pardon me? Where's the?
Yeah, at the URL bar, you type in view source, view hyphen source and colon, I think, to the URL.
In the URL?
Yeah.
I don't get it. How do I mean? I can see this. Oh, no, oh, I see. No. Usually, yeah, I know what you mean. That's seeing the source of the HTML page. No, they usually have a link to the actual source code of the JavaScript that run. Yeah, it's not the same as looking at the source code to the web page. They
might have a link of the JavaScript file though in the.
I mean, oh yeah, but there's usually they have a more direct way of you seeing the source code than trying to spelunk through the HTML. Let me see. Let me look at the. They used to make it really. They used to have a button that just said source code, and it's missing now. Say again. Huh. Yeah, it used to be just a button that just said source code. You know, it would take you immediately to the source code for this.
Or the button on that has the two greater than and less than signs.
Oh, yeah. Great. Yeah. See, there's the GitHub site for the source. Thanks. Yeah, that's the GitHub site for the source code for that example. Okay. Okay. So yeah, I forgot. Yeah, I should have. That looks like the arrows for next and previous. And for some reason, I forgot that there are people using that symbol for source code. I was thinking, oh, that points you to the next demo, because it also looks like the little arrows that would point forwards and backwards. Okay. Yeah. So you click. So on any of these, you know, you can click on a demo, and then you could see the source code for it. And they take you to a GitHub repository for the source code. Okay.
Did they use that because everything in JavaScript is like inside those?
I don't know. That's kind of a more recent little trick that I forgot about that. But you know, this idea of using this symbol to mean the source code. Oh, where else do you see that?
There's tons. Everything's encapsulated in those in JavaScript, isn't it?
Well, in HTML, those are the brackets for HTML. Okay. Yeah. I don't know if they got that idea from the HTML brackets. I've seen a few other places that use that kind of a symbol to mean the source code. Yeah, maybe it came from. Yeah, those are the angle brackets for XML and HTML. Okay. All right, and there's a bunch of the here's another example of a JavaScript library. Okay. Oh, see here they did the old-fashioned way. A button that just says source code, okay? Yeah, and you can look at any one of these examples. Okay, so you can look at examples and see the source code. Let's see, I'm trying to think where they have a whole, let's see. Oh, this is more or less, they keep changing one example. Yeah, so there's a lot, they're showing you this teapot, but they're showing it to you in lots of different ways, and you can always click to see the source code of that example. Okay, you know, and one of the classic ways of learning the program is monkey see, monkey do. You look at the code and just mimic it. Copy and paste, just whatever you see in the code. If you see something you like, you go ahead and just mimic it. That's a really good way to learn programming. Now, all this stuff is written in JavaScript. Yeah. This is a 2D graphics library written in JavaScript, Paper.js. There's a lot of very interesting stuff in here. Okay. Notice that here, the graphics is responding to my mouse. Okay. And we'll learn how to do, that's one of the things we'll be learning is how to do an interactive graphics that respond to mouse or keyboard, things like that. Okay. So there's a lot here you can look at. I mean, I pointed to a whole lot of examples that I thought are fun to look at. There's thousands, there's a lot of these on the internet. Yeah, there's any number of this kind of stuff on the internet. Okay, this one's using a library called Processing. This is another 2D graphics library, real famous one called Processing. Okay, all right, so that's just fun. I thought it'd be nice to have a list of things. If you just want to browse some interesting graphics, this is just a few. There's, the internet is full of people doing interesting stuff with computer graphics, especially in JavaScript. Now, games are actually written almost always in C++ or C#. The two most common language for writing games right now are, well, JavaScript for online games, and C# and C++ for more heavy-duty games. C# because of the Unity game engine. Unity game engine is in C#. So, I mean, as far as I know, C# is only used by Unity, but that's a pretty big one. And then everything else is pretty much written in C++. Okay, and not too many games are written in Java. Right now, Java is more of a big data. Right now the Java language is much more popular for big data and server stuff. It's fallen out of favor for graphics, but it's the language we use for this in our curriculum. So, and it is a good graphics language. There, a few years ago, there were quite a few games written in Java. For a short time, there actually were quite a few games being written in Java, but then it kind of just fell out of favor. Okay? But it is a good language for it. It's a good object-oriented programming language. It makes it, if C# works for graphics, Java will too, just as well. The languages are almost clones of each other. So it's just that right now there are very few commercial games that I know of being written in Java, but it's a lot of graphics textbooks still use Java as the language for teaching graphics. Okay, and in our case, everything will be written in Java, and you'll do your homework assignments in Java. Okay, all right. So let me start by downloading this software with these two zip files. So I'm going to download this zip file and download this zip file. Pay attention to where you download. In this case, I'm downloading them to the desktop. Okay, I'm just downloading them to my desktop here. Okay, so I've got these two zip files.
I tried downloading the renderer earlier. There was a problem. Yes, Unicode in one of the source code comments, so it wouldn't compile.
Pardon me?
You had Unicode in one of the comments of the source code, so it wouldn't compile.
Oh, okay. I'll have to look. Yeah, we'll see. Okay, let's see if it's still there or not.
Yeah, that plus minus symbol.
Oh, that thing. I'll show. That seems to cause problem for only. Okay. Yeah, we'll look at that in a minute. I like those little plus minuses, and they don't stop my version of Java from compiling it. But I know, yeah, some other people have pointed out that I don't know. There seems to be some versions of Java that don't like those little plus minus symbols, and I'd like to figure out a way to, because they're great. They make it nice for writing documentation to be able to just write a little plus minus symbol. Let's see. I got a little flashing thing from Zoom. I don't know if somebody's waiting in the room. Okay. Yeah, we'll have to look at those little plus minuses and see what's going on. I'll show you. It won't stop this system from compiling, but you have to. We'll see what it might be that causes problems. Okay. So I don't need the zip files. Okay. Here's the first render. Now here's how it works. Okay. The render is in this folder. Okay, there is a README file in the top level folder. Okay, so read the README. Okay, right. So the README describes is part of the documentation of the system. Okay, so here's what we're talking about. This is the definition of what a renderer is. A render is three things: an input data structure, an output data structure, and some algorithms that process the input data structure to produce the output data structure. Okay, so this is treating a render in a very computer science kind of way. It's algorithms that process input data structures and produce output data structure. The input data structure is called a scene data structure, and pretty much I try to use, even though I wrote this thing, I try to use terminology and I try to model the code on the way real graphic systems are. If you go out and look at OpenGL or 3JS or Direct3D, I try to use the same data structures, the same terminology that everybody else is using. So the input is commonly called a scene data structure, and the output is referred to as a frame buffer data structure, a buffer that holds one frame of your movie or your image. So they call it a frame buffer data structure. This is going to be the data structure that holds the pixels we're going to talk about. And then there's algorithms that read this data structure and write this data structure. And most of the time in the course, your first homework assignment is to learn about this data structure. Your second homework assignment is to learn the basics of this data structure. And then as the semester goes on, mostly what we're doing is we'll be adding to the algorithms. The frame buffer data structure never changes the whole semester. The frame buffer data structure is a frame buffer data structure. Once you know the basics of it, it doesn't grow. The scene data structure will grow as the renderer gets more elaborate, and the rendering algorithms will grow as the render becomes more elaborate. So most of the homework assignments and most of the homework assignments will be about the scene data structure. You will be mostly working with this data structure, and we'll learn the rendering algorithms. You're not going to have homework assignments where you have to write the rendering algorithms. So we'll learn the rendering algorithms, but they're real basic. So there's not much you can do to modify them or anything like that. I've had people do senior design projects where they've modified the rendering algorithms, because that's kind of a bigger thing to do, is to play with the algorithms is more project than homework assignment. So your homework assignments will be working with scene data structures, but we'll be learning the rendering algorithms and how they manipulate the scene data structure. And like I say, the frame buffer is the frame buffer. It doesn't change the whole time. Okay. Then the render is divided up into 1, 2, 3, 4 packages. So these are Java packages. This package describes the frame buffer data structure. This package describes the scene data structure, and the scene data structure is actually made up of several classes: a camera class, a line segment class, a model, a scene class, and a vertex class. Okay, so this is the output data structure. This is the input data structure, and pipeline holds the rendering algorithms. We'll see that graphics systems are usually referred to as graphics pipelines. Because of the way they work, it's real common to refer to them as a pipeline. So here is the algorithm. There's actually at the beginning only 2 algorithms: projection and rasterization. Okay, so the pipeline has only got what we call 2 stages in it at this point. We'll talk about these 2 stages. Eventually, the graphics pipeline ends up with about 20 stages in it. Okay, but it starts off with just 2 stages: what's called projection and what's called rasterization. So this organizes the algorithms. These are the two rendering algorithms that we start with: projection and rasterization. Okay. All right. And then there's also a 3rd package here, or 4th package, which is a bunch of geometric shapes. They're just, we need something to draw. If we're going to do graphics, we need something to draw. So this thing can draw a cone and a circle and a pyramid and a sphere and a torus and a icosahedron and an octahedron. So I have a bunch of different shapes predefined. We'll use these every once in a while. You might read some of the code in these, but we won't look too much at this code here. Mostly we'll be, in this case, mostly we'll be emphasizing the frame buffer, the pipeline, and the scene. And every once in a while, you'll be as homework assignments, you'll be writing. These are called models. Each one of these models a geometric shape, and you will write some models as part of your homework assignment, but they won't be as elaborate as these. I wrote the more complicated, elaborate models as demos, and so we can play around with graphics. and then you'll write some simple models to learn how models work. Even here, there's some simple ones, like a cube, like there's a cube model, and a triangle model somewhere. Okay.
Hello, Professor.
Yeah?
There is a student waiting to get into the class.
Oh, there's
Can you
somebody
check that?
waiting?
Yes.
How can you tell? Did they send you emails?
He told me that. She's
Oh,
my
okay.
friend.
Okay, yeah, that's a good point. Okay, yeah, it looks like there's 2 people. Okay, so they're in now. Okay, that's
Okay,
great. Yeah,
thank you.
yeah, Zoom has got too many things going on. Yeah, so it's real hard to be talking and watching all the things in Zoom. So that's a good point. If you're late, send a message to somebody who's in the class, and they can let me know that there's somebody waiting to get in. That worked well. The Zoom interfaces, I'm not good at keeping track of people waving their hands and people asking to be, and the admission thing is a security feature. Last year we didn't have to even do that, but people started Zoom bombing meetings, and so Zoom set their system up so that you have to admit people, which is it's actually kind of a nuisance, but that's supposedly more secure. So yeah, if you do come in late and you're wondering like why you're not being admitted, it might be a good idea to send a message to somebody who's in the class. They can point out to me that there's somebody who wants to get in. Okay, all right, I think everyone's in now. All right. So now here's how we can use this rendering system. Okay, we're going to use a real simple build system for this. Now, every piece of software has to have a build system. I mean, once you get past a piece of software that's just 1 or 2 files, you have to have a way of building the software. In Java, the build systems that are commonly in use are Ant, Maven, and Gradle. And we don't need we don't need anything that complicated. This is a pretty simple system. So the build is going to be just a script file, okay? And this is a Windows script file, and then here is a Linux script file that just say Java compiler, all the files in one class. See, this will compile all the Java files in one of the packages. Then it'll move to the next package and compile all the Java files in that package. Then it'll move to the next. So it just steps through the packages and compiles the files in each package. Okay, that's all you really need. Okay, and then notice that the commands are actually the same. It doesn't really matter. The only real difference between Linux and Windows is the file separators. See, Windows uses that file separator and Linux uses that file separator. Okay. Okay. So there's just a difference in separators. And I gave the Linux one this encoding. Now, that might be why some of you are having trouble with the little plus and minuses. Java has a notion of a character set, and it has several different character sets it can use. And if you use the wrong character set, usually you use the default character set. And I think those Windows and Linux don't use the same default character set. Okay, so it seems that the default character set in Windows works fine with the little plus and minuses. And for Linux, I think I told it to go ahead and use the Windows default character set. So on Linux, I'm building using this encoding, and it seemed to work fine for me. Okay, and for Windows, I just use a default encoding, and it seemed to work fine with the little plus and minuses. If the plus and minuses are giving you problems, you're probably using a version of Java that for some reason is using a different default character set. Okay, so you might be able to fix it by throwing this into your build. Okay, now if I just double click on this batch file, okay, and notice I'm on a right now I'm working on a desktop that I don't use very often. This is not my usual desktop, so I haven't clicked on a command file in a while. Windows, wants to pretend that this is a dangerous thing to do. Okay, you just say run anyway. I think it'll only ask you that once. So it's stepping through the batch file. And what it just did is it compiled all my files. So now if I go through here and I look at, say, the render, and I look at the scene class, see, everything's been compiled now. Okay. And then if I go over here and okay, let me, see this, there's a clean. See, if you click on the clean batch file, this is going to be annoying. See, it deletes all the class files. It cleans up. It's like build clean. So it's just like if you're using, it's just like if you're using make files. So this will be make build. This is make clean. So if I go back and build all the classes, you'll see that it's stepping through all the packages. See, it just went through that package. Okay, and it went through all the packages. And there were no compiler errors. Okay, and then build clean cleans it up. All right. Now, another thing you can do is all the class files in the render have fairly extensive Javadoc to them. So here's a build Javadoc command. So you double click on it. Damn, does anybody know how to get rid of this stupid thing? It doesn't happen on my other desktop. What could it be? How do you make this go away? It doesn't do.
Run as admin.
Oh, no, that's the whole point, is there's no reason in the world why I should be running anything as admin. That's the wrong answer. Yeah, you don't want to run things as admin. That's the stupid Windows way of doing things, where you just say, oh, just become admin. That solves all your problems. That's a very bad strategy. Unfortunately, that's Microsoft's answer to a lot of questions. No, I mean, it doesn't happen on my other desktops. Okay, now this step through all the class files and is compiling their Javadoc, and it created this
Professor?
folder. Yeah.
I would assume that that setting is probably somewhere in like Windows Defender. If you probably turn that off, it'll stop from scanning probably like everything that you're opening.
Let's see.
Probably in the settings.
Oh, maybe it's going to do it like every time I click. Maybe when I click on a new file, it'll do it the first time I click on a file. Okay. Yes. I think what it's doing is the very first time I click on a file, it stops me. Okay. So, yeah, it just...
Jonathan put something in the chat. It's like step-by-step of how to turn it off.
Well, it doesn't... If it only does it the first time, it doesn't really bother me. Yeah, so you notice that it doesn't do it again. So if I click on build Javadocs the second time, see, it doesn't warn me again. So it seems to be only doing it the very first time you click on a CMD file, which that's not a big problem. If it only does it one time. Okay, notice that building the Javadocs creates this HTML file, this folder. You'd open it, and then you click on index. And then you get the Javadocs to this library. Okay, so this is the entry page, which is the same thing as that README. That README that was in the top folder, it's part of the Javadoc here. You click on, there's the frame buffer class. You can read the Javadoc for the frame buffer class. You'll need this for your first programming assignment. The first programming assignment is about the frame buffer. Then here's the Javadocs for all the models. Here's the Javadocs for the pipeline stages, the projection stage, and the rasterizing stage. Okay, and then here's the Javadocs for the scene class, the camera, line segment, model, scene, vertex. Okay, so every class file has extensive Javadocs. And you go back and forth between reading to understand the software, you go back and forth between reading the Javadoc and reading the source code. And I actually made the Javadoc link to the source code. So for example, here I'm in the Javadoc for, let's see, I'll go to this model class. Okay, here's the Javadoc for the model class. The model class has got some fields, it's got some constructors and some methods. If you click on a method name, it gives you the details about the method. Then if you click on it again, it takes you to the source code for the method. So the source code is linked into the Javadoc. Now you're reading the source code as Javadoc, so this is not editable source code. If you want to actually, this is not compilable, editable source code. It's just source code as HTML. But that's one of the features you can do in Javadoc. If you want, you can have your Javadoc compile the source code into web pages. Okay. So I had this Javadoc do it that way. So when you're reading about this method, you can click on the name of the method, and then, see, there's the Javadoc that we were just reading. See, that's the Javadoc comment, but then there's the method code itself. Okay, so everything is Javadoc. Everything is commented pretty extensively. Okay, so I'll close this. You don't need to keep the HTML folder. You can just delete it, because you have this build script here. We'll build, and then the building of the Javadoc, if you want to know how. Now, one of the reasons why here's one of the reasons why I want to do this. What happens when you use large packages like Eclipse and JetBrains and things like that? They tend to write this stuff for you, but in really obscure ways, and it can be real hard to figure out what's going on. I want everything to be exposed to you. I don't want anything to be hidden behind menus and config files. So here, for example, if you want to see how to build Javadoc, there's the Javadoc command. Okay, that's what a Javadoc command looks like. There's the Javadoc command. It's saying that put the output in a direct, -d means directory. So I chose the name HTML for the directory name. A lot of people like to use doc for the directory name. I use HTML for the directory name, but doc is real common. Then this says to link to, like, for example, if I'm using a Java string class, I want my Javadoc to link to Oracle's string class. So I have to tell Javadoc where to link to. So here it says to link to Oracle's JDK11. Okay? And then I go on and on. Like here, this is what makes it link to my source code. The fact that my Javadoc actually links to the source code was an option in the Javadoc command that says link to the source code. Okay? So, you can put together, you go read the documentation on the Javadoc command. Later on, I can show you where you read that, and it tells you how to write a Javadoc command. And then here, you just, I've written it for you. You can see how it works. Instead of it being buried somewhere in a config file, in a Maven XML file, I think it's just better for you to have the Javadoc command right there so you can see how it works. Okay, and the Linux version of it is exactly the same, because Javadoc is Javadoc. It doesn't matter if you're running it on Linux or Windows, Javadoc is Javadoc. The only real difference tends to be a few little minor things about, let's see, what were the, let's see. Oh, the encoding. See, I had to tell the Linux to use this other encoding. Okay, and again, I think that encoding is there only for those little plus or minus symbols. Okay, so, but for the most part, there's minor differences between Linux and Windows, and the minor differences in things like the default encodings, and like I said before, the separator for folders. When you're typing a path, a folder, in Windows you use these slashes, in Linux you use the other slash. So you have to make sometimes little changes from a Windows script file to a Linux script file. The Windows script files are set up so you can just double click on them. Usually people don't do that in Linux. Mostly in Linux, people would open a command line, and then like here, I can build by just typing. If I want to, I can use the command line here too. Instead of double clicking on scripts, I can use the command line. In Linux, you would almost always use the command line. In Windows, you can either use the command line or you can double click directly. Oh, in Windows, to make the double clicking work nice, I put these pauses after every command. The pause is what makes the Windows box stay there. See how that box stays there? That's the pause command. If the pause command wasn't there, what happens is you run the script. When it gets to the end, the window disappears. Now, the trouble with that is if there were any error messages, the error message would disappear with the window. So since double clicking is a popular thing in Windows, I put little pauses at the end of all the scripts in Windows so that you would see any error messages when the script completed. Yeah. So if there, let me put an example of an error message in here. So I'll go to the scene. I'm going to open up, and I will do the classic, let me delete a semicolon. So now I've got a compiler error. Okay. So now I go here and I build all classes. And I get told that in model.java on line 48, there's an error. Now, this is a build script, so there's nothing that's going to take you to Java line, model.java line 48. You have to go to that yourself. You just navigate to the, you got the error message. You go navigate to where it's telling you the error was. You can fix the error. But it's the pause that lets you see the error. If the pause wasn't there, the error, this window would just go away. Okay, then when you fix things, you just build again. Oh, one important thing, it's all, if you build and there's an error, it's always a good idea to clean before you rebuild. Okay, yeah. In most sophisticated build systems, the build system will do a clean before it does a read. Well, that's not true. There are advantages and disadvantages to cleaning before building. Some will, like Make by default doesn't do a clean before a build because Make won't rebuild things it doesn't need to rebuild. So it really varies. In this situation, with the Java language, you're better off doing a clean before you do a rebuild. If you don't, you can get some weird error messages. Depending on the kind of error you're fixing, the new classes may not be compatible with the old classes, and you can get weird compiler errors if you're trying to recompile something against old classes. So it's better to just, if you've just cleaned some compiler errors, after building and you clean some compiler errors, do a clean and then do a build. It's just a safer habit to get, especially with Java. It's a safer way. With C and C++, usually you don't need to clean before you rebuild. But Java is a little bit quirky about the way it builds things. And I've noticed that in Java, you're better off almost always doing a clean before you do a rebuild. And I think that Java build environments do that by default. C and C++ build environments usually don't. They usually don't clean before rebuilding. Okay, okay. So these are the build scripts, okay? Now, here's okay, let me clean. Okay, so I cleaned everything up. Here's a demo program. Okay, so here's what I'm going to do. I want to run this demo program. Okay, there's two ways I can run it. This is a client program. This is a program that actually runs using this render. Here's a build script for building a client program. So if I just drag and drop that on that program, and then since that's the first time I've used it, I have to say run anyway. That builds the render and runs the program. Okay, the program output is some debugging information, and the program generated this image file, and that's what our 3D renderer does. A 3D renderer draws images. Okay, so this is the first output from the 3D renderer. The 3D renderer drew this triangle. This triangle is actually sitting in three-dimensional space. It's just a flat triangle, so it doesn't look very 3D-like yet. But the renderer drew that. Okay, so now another way. Now, if I click, notice it compiled everything. It compiled when I click. When I use this build and run client, it actually compiles the whole renderer first and then compiles the client program itself. Then if I click on clean, it'll delete all the class files. You can also just open this file in, well, at least I can open it in Textpad. Depending on what editor you're using, depending on how you've got your machine set up at home, at least in Textpad, I can just go over here and say compile, and it compiled everything. See, I can just open that client program in my editor and just click on my editor's compile tool, and it compiles everything. And it compiled everything. It compiled all the class files in the renderer, and it compiled the client itself. And then if I want to run the client, I can just go over here to run the client. Okay, and there's a little pause there to let you be able to see the output, and then that generated this picture again. Now, I like to use Textpad. I think Textpad's a nice little editor. There are a bunch of editors out there. You can be using Visual Studio Code. You could be using Eclipse. You have, if you like to use Eclipse, you may have to modify this stuff to get it working with Eclipse. Like right now, it's set up in a very simplistic way. What we're doing here specifically in terms of Java is this class file is in what's called the default package. Okay, notice that there's no package statement up here, but it's importing packages from the renderer. Okay, so this is the top level default package, and it has these packages below it. Java will work this way. You can just compile this thing by just saying, you just run the compiler, and it will compile this thing as part of the default pack. If you put a package name up here, then this will break it. If you put a package name up here, then you have to work a little harder to get this to all the compile. But right now, this is in the default package. These are in sub packages of the default package, and it just works. Okay, I have to import the renderer packages. Now, if you look at the renderer packages, each renderer package, each one of them begins with a package statement. So this is the scene package in the renderer. This is the scene sub package of render. Okay? And if you look in the pipeline, see here, this is the pipeline file this is in the pipeline package. It imports something from the scene package, and it imports something from the frame buffer package. So I have package statements in all the sub packages, but not the top level programs. The top level programs are what we call the default package. They don't need a package statement. And if you do it this way, if you tell the Java compiler to compile the top level program, it'll just go and compile automatically all the sub packages that are being imported. All the sub packages that are being imported will get compiled automatically. Okay, so all you really have to do is compile this program. If you look at this script here, notice it doesn't say compile all the packages. It just says compile whatever. This is the symbol for drag and drop. When I take a file here and I drag and drop it on that script, the thing I'm dragging and dropping is parameter 1. That's #1. That's the parameter to the script. So this compiles that file. Notice it's not told to compile anything else, but the Java compiler sees the import statements in that client program, and it checks to see if they need to be compiled. So it checks to see if the class files exist. If they haven't been compiled, the compiler compiles them. See, Java is actually its own mini build system. The Java compiler, unlike the C and C++ compilers, which will not do this, the Java compiler actually is a simple build system. So if you tell the Java compiler to compile one file, and that file imports and uses other files, the Java compiler will compile them for you automatically. That makes it kind of nice. So you don't need too many elaborate build scripts in Java. Okay, so the build script for build and run client literally just says compile the client program, and then all the other files that are needed get compiled as the compiler sees them. As it's parsing this one file here, and it sees imports, it compiles whatever it sees it needs. Okay? So that's the simple build system that we're going to be using. It's just, you can do everything in this folder. You don't even need an editor. So this script file here will build any one of these programs here. And then, like I say, this one will build all the Javadocs, and this one will build all the classes. Okay? And what I'm using is I'm using this version of Java, the Amazon Corretto 11. Okay, I'm using Amazon Corretto 11. One nice thing about it is, unlike Oracle's JDKs, Corretto puts itself in the path of your system. So if you look at these build scripts, see, it just says Java C. It doesn't say where to find Java C. In the old days, when we used Oracle's compilers, Oracle did not put its compilers in your path. So you had to type the full path to wherever that compiler was. Corretto puts itself in your path if you run the installer. So I'm using the version of Corretto that was the, where is it? Oh, here, the MSI version, not the zip file version, this one. So you download it and you double click it, and it installs itself and it puts itself in the system path, which is real convenient. Just like Linux. I mean, Java on Linux does the same thing. Java on Linux has itself installed in the system path. So it's nice to have Java installed in the system path on Windows too. For some reason, Oracle never wanted to do that. Oracle never put itself in the system path. So you always had to, when you wrote build scripts in Oracle, you always had to build in the system path into the build scripts. But the Amazon Corretto distribution puts itself in the system path, which is, I think, a nice feature. Nope. People are moving away from the Oracle distributions of Java. There's a variety of legal and technical reasons for people moving away from the Oracle distribution of Java. And it seems that right now, the Amazon Corretto distribution is real popular. Another one is OpenJDK. I don't know if it puts itself in the path. So this is another distribution. I've settled on Oracle. I think Oracle works pretty well. They've got a nice system for downloading and installing. So, I mean, this is another real popular distribution of Java. What people aren't doing anymore this is Oracle's. Oracle has made important changes to their license agreements, which are upsetting a lot of people. This is the main problem. Oracle has been making all kinds of changes to their license agreement. Java from them is actually technically not even free anymore. And if you're a company and you use their version of Java, you may actually have to pay for it. This is a completely free and open version of Java, and this is a completely free and open version of Java. This is not. So a lot of people are moving away from Oracle's JDKs because they're no longer free and open. Some companies are required to pay. I don't know quite who, but some companies are required to pay for it, and that's scared a lot of people away from their version of Java. Okay, so we're not. I mean, you can any version of Java that works for you is fine with me. Okay, I'm on my machine. I'm using this one, and I'm assuming in the build scripts that you have Java in your path. Okay, so the Java compiler and the Java virtual machine are just like in Linux. I'm assuming that they're in the path, which makes things a lot easier. Okay, all right. Now, let's look at a little bit of what the homework assignment is about. Okay, so if you go to the homework page, okay, here's the homework assignment described on this page. You need to download this zip file, okay? So I downloaded a zip file for the homework assignment. I'll unzip it. This homework assignment only uses the frame buffer out of the, it only makes use of the frame buffer out of the render. So it only uses the frame. There's no other part of the render is going to be used in this homework assignment, okay? The frame buffer holds the final output image of what the render produces. It holds the pixel data that is the 2D picture. Like here's a 2D picture. Okay, what we're looking at here is really a frame buffer. We're looking at pixels. You know, your computer screen is made up of what we call pixels. The computer screen is actually a bunch of dots. Okay, now let me show you what I mean by that. I downloaded that folder of pixel utilities, and here's the folder of pixel utilities. So let me open it. Here's a pixel utility. What this thing does is it magnifies your desktop. There's a little slider here that controls the amount of magnification, okay? And right now, let's see, I want to follow my mouse. Now, see, as I move my mouse around, let's see, it's a little bit slow. Uh-oh. Okay, now as I move my mouse around, notice that it's magnifying, but the trouble is, this is an older program, and there's a mismatch between where my mouse is and where it's zooming in. Notice it's zooming in on a Q. Okay, I'm not pointing at a Q. I'm not sure where that Q is.
It's the quick access to the left and up. Go to the pictures and then go up. And so it's like diagonal this way is going.
On this window here, or?
Yeah, your quick access, go where you're at, go left and up, and you'll see the quick access. That's where it's at. But you're down at Zoom Plus, and it's to the upper left.
Yeah. Oh, I see what you mean. Yeah, the little star. Yeah. See, yeah. You say what this is. Modern computers are a royal nightmare because of years of bizarre compatibilities and changes. Here's what's happening. Windows is what this desktop has kind of a high density. It's kind of a high density pixel desktop. It's magnifying the pixels. If you go down here and you go to display settings, see this 100%. My Windows is magnifying everything on my desktop by 125%. That's because modern desktops have smaller pixels than older desktops, okay? This program's kind of old, and I haven't been able to find a good modern version of this program. This program does not know about the magnification. So it is mixed up about where it's pointing at. When the mouse is over here, because of the magnification, and this program doesn't know about the magnification, the program thinks it's somewhere else on the screen. So it's magnifying the wrong thing. Now, right now, that's not so much important. What I really want to show you is the fact that your screen is actually made up of pixels. See, if you look at things, see how everything is made up of little square dots. Your actual desktop is, if you held a magnifying lens to your desktop, you would see these little square dots. Your desktop is made up of little square dots called pixels, okay? And every image on the computer screen is really just a bunch of pixels. And the frame buffer, see if I can find this little guy here. Where am I?
Excuse me, Professor.
Uh-huh.
Could that also happen because the point of origin, the 0, mark in your coordinates plane isn't necessarily in the same spot? Like it was in one of those chapters that was explaining, like if it can distort pictures if they're set up.
That's not the case in this case. In this case, the problem is that magnification. In this case, this program's too old to know about the magnification. I need to find a more modern version of one of these magnifiers. unfortunately, I haven't found a good magnifier lately that knows about magnification. Here's another one. See, this one's magnifying also, but again, it's in the wrong place. See, and it knows how it's off by the exact same thing the other one was. I'm over here on this icon, and yet the magnifier is over here on this quick access thing. So this one's off by the same amount, and it's because that these programs are older and they don't know about the screen magnification. If you know a good Zoom program, let me know. If somebody knows a good modern Zoom program that doesn't have this problem, it'd be, now there's another one, Zoom. This one's new, but this one's kind of harder to use. I don't like this one as much. It runs out of the tray. Where'd it go? I forget where it. There, see, it magnifies the whole desktop. It's a different kind of magnifying program. It magnifies the whole desktop rather than just magnifying where you're, yeah. And it's a little bit trickier to use. That's this one here. If anybody knows of a good little, like this one used to be the best one. This is a really nice zooming program, but it doesn't know about, so you can control the amount of zoom, but it just doesn't know about magnification. So it's always zooming in the wrong part. You know, it doesn't follow the mouse properly. And as far as I know, there is no update to this program. Okay, now, so a computer screen is nothing but a bunch of pixels. What we have here is a piece of software that holds pixel data. So that's this frame buffer class here. Okay, you have to write a program that puts data in a frame buffer object. So your program is going to, yeah, okay, here's the outline of your program. You're gonna have to read the documentation that comes along with the okay, you read the documentation that comes with homework, with renderer 1, and read the web page that is for this homework assignment. Read this web page, and then you follow the outline of this code here. You're going to instantiate a frame buffer and fill it with, you have to fill it with data to make it look like, I'm sorry. You have to fill a frame buffer so that it holds this information here. So what you're going to do is you're going to write code that puts, like this is an array of, you can see down here, it's 1,000 pixels by 600 pixels. There's 1,000 dots across here and 600 dots across here. Each one of these squares is 100 pixels square. You actually have to, you're going to create a frame buffer that's 1,000 by 600. It's essentially a 2D array that's 1,000 by 600. Then you have to write a bunch of for loops to fill it in with the pixels of these colors. Okay, these colors, you find them out by using one of these pixel utilities. So for example, if this pixel utility, there. See, now it's showing me the color. That color is, this shows you the let's see. See, this color has got, every color has 3 numbers. So if you see up, that color is number 255, 189, 96. So that's this set of 3 numbers here. That's called the RGB of the color. So you're going to be, you need to examine this picture using this software, and you get, see, there's one of the colors. There's another one of the colors. See if I can find the disk.
Excuse me, Professor?
Uh-huh.
Jacob had a question in the chat. What does the 24 BPP and the dimensions stand for?
Oh, each one of these colors, see there's 3 numbers here for the color. There's a red amount, a green amount, and a blue amount. Each one is 1 byte. That's why there's 255 possible values there. Okay, so each color, there's 255 1 byte's worth of red, 1 byte's worth of green, and 1 byte's worth of blue. Okay, 3 times 8 is 24. That's the 24 bits per pixel. So what this is saying is that this picture holds 3 colors per pixel, a red color, a green color, and a blue color. Each one is 8 pixels, and so there's a total of 24 pixels, 24 bits. I'm sorry, I said bytes a minute ago. It's 24 bits per pixel because there's 3 8-bit bytes per pixel. Okay, so it's 1,000 pixels across, 600 pixels down, then each pixel is 3 bytes, and 3 bytes is 24 bits. And each byte represents a red, a green, and a blue value. Okay, so for example, here's white. White is all red, all green, and all blue. And if you see, the color is 255, 255, 255. That's all, everything is turned on. Let me see if I can find black. If I get lucky and I land on black. Okay, there's something that's close to black. Notice that it's almost 0 for everything. See, black would be, there, 0, 0, 0 is black. 255, 255, 255 is white. When you mix all the colors together, you get white. When you have no color, 0, 0, 0, you get black. And then every other color is some in between, is some mixture of red, green, and blue. So every possible color is a mixture of red, green, and blue. Okay? So you can, now we need to get a better, we need to get better these pixel tools, because I've been looking around and I've not been able to find better ones than this. These are too old. They don't know about the screen magnification. So they're a real pain to use right now because they don't know about the screen mag. There might be a way to tell them about screen. One thing you can do, but this is kind of a pain to do, is if you turn off the screen magnification, then they work fine. I'm sorry. You click on your desktop and you say display settings. You can turn off the magnification, but it's not really, that makes all your programs shrink in size and they become a little bit hard to use, but you can turn this off and on. But if you turn off the magnification, notice that this thing works perfectly now. See, now it knows exactly where I am. No matter, anytime I point to a pixel, it's dead on. See, it's always dead on a pixel. Okay, and then if I want the magnification back on, I can just turn it back on. Okay, so it's pretty easy to switch between off and on. Notice how when I turn off the magnification, everything kind of shrinks. Okay, depending on your desktop, they might shrink a lot, and they might shrink, depending on the resolution of your monitor, they might shrink a lot and become kind of hard to read. So Windows does this automatically. Windows chooses the right magnification for you. And you can tell your desktop will say which is the recommended one. Like with this laptop, 125% is the recommended magnification. Okay, all right. So you can use these zoom tools, but you may have to, unless we can find more modern zoom tools, I'm going to keep trying to find better ones. But these older ones don't know about magnification, but you can turn the magnification off. Okay, all right. So we run out of time. We're running at the end of class. On Thursday, we'll start off with looking at, you can start reading the README to the renderer 1. That explains a lot of what we're talking about, and read the homework assignment, and then we'll start talking about the frame buffer class. So we'll start class on Thursday talking about the details of the frame buffer class and what you need to do to set things up for the first programming assignment. Okay, but pretty much most of what you need is read this section here. This is the one that, see, there's a picture of the frame buffer. There's the idea of the frame buffer. Okay, So there's a small frame buffer, 7 rows by 8 rows by 12 columns. That's a super small frame buffer. You're going to be working with a 1000 by 600 frame buffer. Read this explanation of what a frame buffer is and what pixels are, and then read the README that comes with the render 1, and read the description of the homework assignment. Remember, there's no textbook. There's just all these little readings, but and then we'll start on class on Thursday. We'll jump into how to work with the frame buffer. Okay, and if you have questions, send me an email. Make sure you can build this stuff on your computer at home. Download the render. Download the render and just make sure that you can build the render. Build one of these. Here's another example. Let me just show you real quick. Build that example. It builds a little more elaborate 3D scene. See, there's a little 3D scene. Okay, so make sure you can build these renders. Make sure you can build the render and run these little example programs, and then we'll start talking about the details of what the frame buffer is. And if you have any questions, please send me an email or request a Zoom meeting, especially if you have trouble getting anything to run. Okay.
Can we try this on Linux or should we do it on Windows?
Oh no, I put the build scripts there for that purpose.
Okay.
Yeah, see, I put Linux build scripts in there, so you should be able to just open a command line. Oops. You should just be able to open a command line in. Yeah, in Linux, you should be able to open a command line and then just run the build scripts from the command line. Okay. So, just like I can do it here on Windows, you should be able to build the build script. Oh, that I ran the Linux build script. That's, wow, the Linux build script even worked on Windows. I never tried that before. These scripts are so generic that Java even understood the Linux version of the build script. Okay, so yeah, you can use this stuff on Linux. You just open a command prompt and just run the build scripts. Okay, that's what we mean by Java being platform independent. That's one of the beauties of Java. There's really no Windows code in any of this. It's Java. It's all Java code. It's platform independent. And these output pictures are here's something real important. I'm sorry, I forgot to tell you about this. Windows does not know how to look at PPM files. PPM files are real popular with graphics people, but Windows doesn't use them. I'm using something called IRFran View. If you're using Windows, you probably need to install IRFran View. I'm sorry, I forgot to tell you about that. You will probably need to install this program. It's a great freeware program for working with images. We'll make a lot of use of it. IRFran View knows how to open these PPM files. Windows doesn't. Unless you have a really good image file viewer on your program, if you just default to Windows, Windows does not know how to open PPM files. PPM files are the default image format for playing around with computer graphics. We'll talk a little bit about them on Thursday. So graphics people use them all the time, but they're good for playing around. They're not something you would use on the internet. On the internet, you use PNG files and JPEG files. But for playing around with computer graphics, PPM files are the most popular. So you will need probably to put something like IRFan View on your computer so that you can just double click on these PPM files and open them. Okay? All right. So again, if you have any questions, send me an email or request a meeting. And it'll take a little while to get everything working. It's not a super sophisticated system, but it is a little bit new, especially since like these PPM files being oddball files, oddball to anybody but computer graphics people. So like I say, Windows by default won't open these files, so you'll need a better viewing program, and I recommend IRFan View. Okay. In the Pixel Utilities folder, I put a shortcut to IRFan View. So there's a shortcut to it in that folder. You need to download it and install it. So I put a shortcut to it in the Pixel utility folder because that's the best Windows view image viewer out there. Okay, okay, we should stop. We've gone over time. If you have any kind of question, just send me email, and I'll put the video for what we've been doing up on the website. So a little while after I have to convert it and upload it to YouTube, but it'll show up on the course website. So on the course website, there'll be a link to the video right here. Instead of there being a link to the Zoom meeting, I'll replace that with a link to the video of what we've been doing. Okay? All right, so I'll stop sharing, and then I'll go ahead and end the meeting now. Okay? So see you on Thursday. Bye.